Hello students, welcome to the interesting chemistry where you will enjoy a classroom teaching. Today I am going to explain you a very important question. What is lanthenide and actinide contraction? This question is oftenly asked in your examination, having the weightage of 1.5 mark or a 1 mark. So I am going to explain you this about the lanthenide and actinide contraction. First I will explain you what we mean by the contraction. It is contraction in the atomic size. Means you will find a contraction, a shrinking in the atomic size of the lanthenide and actinide. That is called lanthenide and actinide contraction. So, explain this contraction. You should know about the elements of the F block elements. As you know, there are two types of the elements that are called actinides and the lanthenides. The 14 elements that are placed in the periodic table after the lanthanum are called lanthenides, and the 14 elements placed in the periodic table after the actinium that are called actinides. Now, to learn about the lanthenide and actinide contraction, you should know about the electronic configuration of these lanthenide and actinide or the F block elements. So think about the general electronic configuration of the lanthenide or of the F block elements is N-2 F 1 to 14. 1 to 14 means from 58 cerium is start from cerium 58. So the 59th electron 1 to 14, the 14 electrons will be occupied by the N-2 F. And then N-1 D 0 to 1. Sometimes it is 0 because the D electron is transferred to this F1 and so on. So we will write here 0 to 1 and NS2. This is the general electronic configuration of F block elements. F block elements. Now I will show in the diagram. Suppose this I am taking. So this actinides you will find this actinide in the 6th period. So there will be 6 orbits or cell in the electronic configuration of lanthenide. Now these are the, suppose this is 1, this is 2, 3, 4, 5 and 6. These are the 1, 2, 3, 4, 5 and 6. This 6th one is N. Suppose this is the last N. This has 2 electrons. This one is N-1, this one is N-1. So S2 and S2 and P6 are fulfilled here. And now come to the F. This one is the N-2. N-2 F. Here this one is the N-2. So in actinides, the 58th or the filling of the N-2 F orbital starts. 50, this one. So the newly entering electron will occupy its place in the 4th cell. In the 4th cell. As the filling of the N-2F starts, there you will find two changes, two effects in the size of the atom. One effect is decrease, and second one is increase in atomic size. Atomic size, I think, as the filling of the n-2 orbital starts, the size of the atom, you will find the two changes, two effects. One is the decrease and second one is the increase in the size of atom. Now understand, this is the entering electron, newly entered electron. This electron is very close to the nucleus. So this electron will experience the maximum nucleus attraction, or this electron. So the size of the nucleus, this portion will get shrinked, will get contracted, will decreased. Here the size of this will be decreased. On the other hand, this, due to the entrance of this electron, the repulsion of the electron will increase, the shielding effect will increase. Hence, when this electron and due to this electron, this outermost cell electron will experience less attraction of the nucleus due to so in other way you can say the ENC for this electron will reduce. Hence, over the repulsion, this repulsion causes the expansion in the size of the electron, the size of the atom. So I think that this is the decrease. From here, this is the decrease, and this one is the increase. So there is a decrease and increase in the atomic size due to the filling of the n-2f electrons. So on comparing this decrease and increase, both cancel to each other, but there is somewhat more decrease in comparison to the increase. In comparison to increase, so you will at the resultant, as the resultant, you find a little decrease or little shrinking in the size of atom of the lanthanides. That is called lanthenide contraction. So I think that you have understood. In the same manner, you can explain the actinide contraction. But here you should think about it. These actinides are placed in the 7th period. So you will find here 7. So that again you will say the ending of the n-2 electron. The filling of the n-2 electrons causes two effects in the atomic size of the atom. That is, one is decrease in size and second one is the increase in size, in atomic size. Decrease is due to that this electron is very close to the nucleus, so this electron will experience more attraction of the nucleus than the size of the from this portion will be shrinked. This portion will be shrinked. And on the other hand, due to the entering of this electron will causes the n-2f electron will causes the repulsion to the outermost cell. This is so you will find, so there will be an increase in the size of atom. on comparing the decrease and increase of the size, you will find a very little decrease in the size, because both the decrease and increase both will cancel to each other, but the decrease is more than the increase, so then at last you will find a very little decrease in the atomic size of the lanthanides. That is called lanthenide contraction. And when you will compare the lanthenide contraction and actinide contraction, actinide contraction is more than lanthenide contraction. Actinide contraction is more than lanthenide contraction. Why? Simple. Because in the actinides, as the atomic number increases, so the charge of the nucleus increases due to the increasing number of protons. So this attraction, the charge, when the charge of the nucleus will increase, this contraction will be more in actinides. So the contraction in the actinides is more than lanthanide. I think that you have understood all about it. That's all for okay. Please watch this video from beginning to end and share to your friends so that they can also take some benefit of these videos. So that's all for today. Thank you very much.